Organic chemistry is the study of carbon compounds where the carbon is doing what is called catenation, and catenation is the forming of long chains. Carbon is very unique in the fact that it is able to bond with 4 different electrons sharing, and it forms a lot of non-polar covalent bonds, so you land up with a situation where you land up with the CH4 and various permutations of that, making more and more different molecules. You need to know some definitions. You need to know that a hydrocarbon is a compound that contains only carbon and hydrogen atoms. You need to know that a functional group is an atom or a group of atoms that form the center of chemical activity of the molecule. You need to know that a homologous series is a series of similar compounds which have the same functional group and have the same general formula, and each member differs from the previous one by a single CH2 unit. You need to know that a saturated hydrocarbon or a saturated compound is one where all the bonds between the carbon atoms are single bonds, whilst an unsaturated compound is one where at least one double or triple bond is in the carbon chain. And finally, another definition, isomers. Isomers are compounds that have the same molecular formula but a different structural formula. When we're looking at hydrocarbon chains, you get alkanes, only single bonds, alkenes, there's a double bond in the molecule, and alkynes, where there is a triple bond in the molecule. The other functional groups you need to know are haloalkanes, where there is a halogen attached to the carbon chain, alcohols, where there is an OH group attached somewhere to the carbon chain instead of a hydrogen, and carboxylic acids, where there's a C double bond OH, and let's just draw that out for a second. So it's C double bond O, OH, and that is attached to the end of the molecule on a carboxylic acid. I'm not going to go through our UPAC naming in great detail because you actually all became quite good at it, but remember you need to look at the length of the carbon chain, and then it's meth, eth, bute, prop, pent, hex, hept, oct, etc. And you need to look at the substituents on it. I'm going to just do a couple of examples with it. This is a carbon chain of 4 carbons, so it's bute something. On it there's a fluorine and a chlorine, which means it's a haloalkane. There's only single bonds, so I'm going to say butane. And attached to that there's a fluoro and a chloro. Well, chloro has got a C to start it. Fluoro has a F to start it, so the chloro wins. And that means that I would label the chain from the side closest to the chloro because of its alphabetical priority. So it becomes 2-chloro. There's only one chloro group, but it's on carbon number 2. 3-fluoro and butane. That would be the naming of that. This is called a structural formula, where I have shown all the bonds between all of the different atoms. Over here we have a condensed formula, where I'm kind of putting little bundles, CH3, instead of showing all the bonds of the CH3, I've put it together. Sometimes if we're going to name something, it's worth taking the condensed formula and opening it up a little bit. Let's just try and do that with this one. So here we can look at the length of the carbon chain. We've got the CH3s, which have been expanded and expanded and expanded. Don't forget about the triple bond. If I'm naming, I have to have the triple bond in the longest carbon chain, and the longest carbon chain in this particular thing is actually going to be 1, 2, 3, 4, 5, so it's pentane. And actually there's not 2 methyl groups hanging off, there's only 1 methyl group hanging off the second carbon, so it's 2 methyl, and it's not pentane. There's a triple bond, so we land up with, it's not 2 methyl either, because the triple bond has to take priority, so it's 1, 2, 3, 4, 5. So it is pent-2-ine, and then it is on the 4th carbon, 4-methyl, pent-2-ine. You need to know how to make an ester. It is called an esterification reaction. and it's when an alcohol combines with a carboxylic acid. Don't forget that esters have got lots of structural isomers. So let's say if I had methyl propanoate, propyl methanoate would also be a isomer of that, and so would butanoic acid. So you mustn't forget that esters and carboxylic acids are often structural isomers of one another as well, just depending on exactly what you're using. So anyway, let's take a look at this. If we were to name it, you use the oxygen as the divider. That's the part that does not have the double bond oxygen on it. That is the part that does. So this is a propyl group, and this is meth. And how do I organize it? Well, the propyl group comes first. So it's propyl, and then it is methanoate. The propyl group is the part that does not have a double bond oxygen on it. So that has always resulted from an alcohol. What made this? It started off with propanol, because remember the alcohol always comes first. I haven't drawn it like that, but once we've named it, then we've got propanol and methanoic acid. I can ask you, methanoic acid, I can ask you to draw out the structural formulas of propanol and methanoic acid if I wanted to, or I could say draw out the structural formula of the products. Here is the structural formula of the products, but don't forget that another product of an esterification reaction is water, and if I ask you to draw it as a structural formula, you need to give me that, which is the structural formula of water. And how is this made? It is made with sulfuric acid as a catalyst and a dehydrating agent. And it's not just sulfuric acid, it's actually concentrated sulfuric acid as a dehydrating agent and a catalyst for this reaction. So that's your esterification reactions. The other reactions you need to worry about are addition reactions, elimination reactions, and substitution reactions. Your addition reactions are hydrogenation, halogenation, hydrohalogenation, and hydration. Eliminations, you're going to dehydrogenate, dehalogenate, dehydrate. And substitutions, you can swap functional groups. Remember what happens in addition is you are going to land up taking a unsaturated molecule and making it saturated. In elimination, you take a saturated molecule and make it unsaturated. And in a substitution reaction, the saturation stays the same, but you are exchanging functional groups, or sometimes just exchanging hydrogen. Now, in hydrogenation, I add hydrogen. In halogenation, I can add chlorine, or bromine, or iodine, or fluorine. In hydrohalogenation, I'm adding something like HCl, or HF, or HBr. In hydration, I am adding water. Eliminations are just the reverse of those. Substitutions, you've got various substitution reactions. You can take alkanes to haloalkanes back to alkanes, haloalkanes to alcohols, alcohols back to haloalkanes. So all of those reactions require special conditions. Now, I will generally give you those special conditions. You should recognize them as being worthwhile, but we're not expecting you to sit and drum into your head all the different special conditions. And if it does get asked for some reason, it'll have a very, very low mark allocation. So if there's one thing that I'm going to tell you to not worry too much is to memorize the special conditions associated with all of these different, what does it work out to be, 2, 4, 6, 8, 10, about 11 or 12 different reactions. I'd rather you put your brain space into something else. Right, please revise all of those. Combustion reactions is when we're going to add oxygen and we get carbon dioxide and water as products. Remember, you're going to need to balance those reactions, and the way to do that is to first look at the carbons, then to look at the hydrogens, and finally to balance the oxygens. In this case, it works out to 2, 19, 12, and 14. How they're going to ask some of the questions regarding the balancing of these, at least the different types of reactions. they could give you something that looks a little bit like this. So it's kind of a flow chart. And what did we start with? We had some hexane. We then had a cracking process. Remember what cracking is? Cracking is dehydrogenation. In other words, we eliminate some hydrogen in the process there. They may say to you, what is another product of cracking? One of the products is ethene, but what comes off as well is some hydrogen is released in the process. Then they might say to you, what is the structural formula of product A? Well, if I had ethene had a double bond, and I add some chlorine to it, I'm going to have an addition reaction, and I'm going to land up with 1,2-dichloroethane, where I add those two chlorines on. They might say to you, what type of a reaction is reaction X? So what have we got? We have got a unsaturated molecule, ethene, turning into a saturated molecule, ethane, and that means that I've had an addition reaction of some sort. What sort? Well, I've added hydrogens, so it's a hydrogenation reaction. So they can present you with these flow charts and expect you to know how did the blocks get from one place to another.